There is a region in space that lies far beyond the planets in our solar system. It represents a frontier of great mystery due to its vast distance and darkness. It encircles the outer reaches of our solar system, extending beyond the orbit of Neptune, the 8th planet from the Sun. What is this region and why is it important? Welcome to Youniverse Revealed. In today's video, we will explore the region that holds the secrets to the solar system, the Kuiper Belt. Spanning approximately 3 billion miles, and likely extending farther into interstellar space, the Kuiper Belt is home to tens of thousands of icy bodies. Once considered a planet until 2006, Pluto now holds the distinction of being the largest known object within the Kuiper Belt. This belt, shaped like a donut, was officially confirmed through direct observation only in 1992. Similar to Pluto, many other objects within the Kuiper Belt maintain stable orbits primarily located beyond Neptune. It's important not to confuse the Kuiper Belt with the asteroid belt. The Kuiper Belt, distinct from the asteroid belt, is colder and positioned farther away from the Sun. Similar to the asteroid belt located between Mars and Jupiter, the Kuiper Belt consists of remnants from the solar system's formation approximately 4.6 billion years ago, as stated by NASA. The Kuiper Belt surpasses the main asteroid belt in size, being up to 20 times wider and having a mass of 20 to 100 times greater. Just like the main asteroid belt, the Kuiper Belt owes its formation to the gravitational influences of massive planets. Jupiter's orbit shaped the main asteroid belt, but it was Neptune's orbit that stopped the material from merging into a larger planet. This separation created the thin disk of the Kuiper Belt. Exploration of the Kuiper Belt has only recently begun, with 2 spacecraft venturing into this region so far. NASA's Pioneer 10 spacecraft visited the Kuiper Belt in 1983, although it did not explore any specific objects within it. Subsequently, the New Horizons spacecraft embarked on a decade-long journey from Earth and conducted a detailed study of Pluto and its moon Charon in 2015. This mission extended to investigating the Kuiper Belt objects like Arrokoth, often referred to as the, quote, space snowman due to its icy composition. NASA emphasizes that the Kuiper Belt represents a giant leap in space. It underscores our ongoing efforts to explore and expand our understanding of this distant region. But what is it that lies within the Kuiper Belt? The icy bodies residing in the Kuiper Belt are called Kuiper Belt objects, or KBOs for short. Pluto was the most famous KBO. One reason it was reclassified from a planet was because thousands of other KBOs were found orbiting in the same area. Only Pluto and Arrokoth have had close-up pictures taken by a space probe. In 2015, the New Horizons probe visited Pluto, followed by Arrokoth in 2019. Pluto is quite round, featuring water ice mountains, nitrogen ice glaciers, and 5 moons. On the other hand, Arrokoth is only 18 miles, or 30 kilometers across, red in color, and shaped like a snowman. All other KBOs have only been observed using telescopes. Even the best telescopes on Earth and in space still view them as dots. So we have limited information about their shapes and colors compared to Pluto and Arrokoth. But what makes these Kuiper Belt objects so intriguing? There are thousands of known KBOs, probably hundreds of thousands, that are larger than 62 miles across. All of them wait to be discovered and studied by astronomers. Each object is a tiny remnant of planetary material. It came from somewhere in the solar system and has orbited in the Kuiper Belt for billions of years. Their orbits were set by gentle nudges from planets in our solar system, or even from the broader galaxy. Now let's talk about the insights that we have gained about the solar system from the Kuiper Belt. By carefully measuring orbits and analyzing composition, we uncover the origins and reorganization of the celestial bodies in our solar system. The study of the Kuiper Belt shows that Neptune formed closer to the Sun before moving outward. Computer simulations have demonstrated that the current KBOs were guided into their orbits during Neptune's movement. Can you guess the most surprising find about the Kuiper Belt to date? It's the space snowman. The most astonishing find for astronomers has been the shape of Arrokoth, which resembles a snowman. In 2014, the New Horizons science team utilized the Hubble Space Telescope to discover Arrokoth. This celestial object is double-lobed and somewhat flattened. It consists of a, quote, head and body, forming a snowman-like structure. It spans 22 miles in length, 12 miles in width, and 6 miles in thickness. Arrokoth is unique in the sense that it is composed of 2 distinct bodies that have merged together. It has created what is known as a contact binary. This unexpected shape has sparked significant interest and has prompted astronomers to find answers through computer simulations aiming to replicate such a form. Understanding how this shape was formed will provide valuable insights into the intricate processes of planet formation. NASA indicates that the inner boundary of the donut-shaped Kuiper Belt commences at the orbit of Neptune. This is about 2.8 billion miles from the Sun. Its primary concentration of bodies extends up to approximately 4.6 billion miles from the Sun. Astronomers commonly measure vast distances like these in the solar system using, quote, astronomical units, or AU. 1 AU is equal to roughly 93 million miles, the average distance between the Earth and the Sun. This situates the inner Kuiper Belt at 30 AU from the Sun, and its main region extends to about 50 AU. Additionally, there is another less organized part of the Kuiper Belt known as the scattered disk. It stretches out to around 1000 AU from the central star of the solar system. These extensive distances establish the Kuiper Belt as one of the largest structures within our solar system. Despite its considerable size, the Kuiper Belt may not be the farthest collection of icy bodies in our solar system. Scientists theorize that beyond the Kuiper Belt lies the Oort cloud, often mistaken for the Kuiper Belt. Short-period objects are thought to originate from the Kuiper Belt, whereas NASA suggests that long-period comets, which take over 200 years to complete a solar orbit, likely originate from the Oort cloud. The inner boundary of the Oort cloud is estimated to be between 2,000 and 5,000 AU from the Sun, although the outer limit could extend from 10,000 to 100,000 AU from our star. This vast range positions the Oort cloud at a distance equivalent to 1/4 to halfway between the Sun and the nearest neighboring star, according to NASA. How do we know all about the Kuiper Belt, and who first discovered it? The Kuiper Belt is named after a Dutch astronomer, Gerard Kuiper. In 1951, he proposed a region beyond Neptune containing icy objects that give rise to comets. Before Kuiper's work, the initial discovery related to the Kuiper Belt came in February 1930. It was Clyde Tombaugh's sighting of Pluto at the Lowell Observatory. Interestingly, astronomers had stumbled upon the Kuiper Belt long before they were aware of its existence. However, the detection of Pluto sparked speculation about other objects existing beyond Neptune. Then in 1943, along came Irish astronomer Kenneth Edgeworth. He published a paper suggesting that the distribution of solar system bodies extended beyond Pluto's orbit. This laid the groundwork for the Kuiper Belt concept. Finally, the confirmation of the Kuiper Belt came in 1992 when Dave Jewett and Jane Liu found a small body beyond Neptune. This discovery marked the beginning of a cascade. It led to the identification of thousands more KBOs. NASA notes that since the detection of the first KBO, astronomers have found over 2,000 more. The delay in discovering Kuiper Belt objects was primarily due to their diminutive size and vast distance from Earth. These difficulties in studying the Kuiper Belt might increase in the future. That's because the Kuiper Belt is experiencing a reduction in mass. Observations of the Kuiper Belt have led to the development of the, quote, NICE model by the University of California, Los Angeles, UCLA. This model suggests the Kuiper Belt's current mass is about 0.1 times that of Earth's. It is too large to have built up solely through accretion over the age of our solar system. This indicates that in the past, the Kuiper Belt likely contained material equivalent to 10 or even 100 times the mass of Earth. This is 100 to 1,000 times more than its current mass. The loss of this mass is believed to have occurred due to the shifting orbits of the giant planets, Jupiter, Saturn, Uranus, and Neptune. NASA explains that as Saturn and Jupiter influenced the outward drift of Uranus and Neptune, they redirected the paths of numerous other icy objects inward. The powerful gravitational pull of Jupiter also propelled objects out into the outer edge of the solar system. This potentially contributed to the formation of the Oort cloud, or ejected them completely from our solar system. NASA states that the Kuiper Belt is still undergoing erosion today. Collisions between objects within the belt generate smaller fragments which further collide, eventually breaking down into dust particles. These dust particles are then expelled from the solar system by streams of charged particles known as the solar wind emanating from the sun. The mysteries of the Kuiper Belt do not end here. This region is also thought to potentially host a hypothetical planet called Planet X. Planet X, or Planet 9, is a hot topic in our solar system. It's believed to be a Neptune-sized planet with a highly elongated orbit far beyond Pluto. The idea comes from observing odd orbits in smaller Kuiper Belt objects, suggesting a massive hidden planet's gravitational influence. But confirming its existence remains controversial due to limited evidence. Today, astronomers find the Kuiper Belt incredibly important to study. And why wouldn't they? The mysteries hidden within its depths hold the keys to many cosmic questions that linger in the darkness of space. So what are your thoughts about the Kuiper Belt?